Hello and welcome to my YouTube channel where you are enrolled in the ongoing series about the DSA. In the last video, we discussed about the linear search. So let's move ahead with the binary search. Today we will be discussing about the binary search and how and why it is very useful and better than the linear search, the standard linear search as we say. Uh, so let's talk about the binary. Uh, so let's understand what the meaning of binary search first is. So and how the algorithm exactly searches your target element in the array. So let's start with the uh, defining an array. Let's say our target array equals our array is 30, 10, 20, 50 and 40. All right. So we will be giving the array two target cases in this case. So it is better if we give it two cases, one where the target is actually present in the array and the other one where the target is not at all present in the array. So let's say our target 1 is 20 and our target 2 is 40 actually 60. Now one thing to know is that binary search can only work if the array is sorted. That means it should be either sorted in ascending or descending order. It cannot be used otherwise. Otherwise you have to actually sort it and then use the binary search algorithm afterwards. In that way we can say that linear search will traverse from one by one, from 30 to 10 to 20 to 50 to 40 till our target element is found. But in the case of binary, we can say that the binary needs to be sorted first. So for the use case of this video and explanation, let's just use the sorted version of the array, which is 10, 20, 30, 40 and 50. Now let's say the array is sorted and our target cases are 20 and 60. Now, in the when we are going to talk about the 20, which is actually present in the array. Now, what the binary array search algorithm says that it has a range. When we talk about ranges, there should be a start and an end pointer in the range. So our start and end. Now we are not defining these start and end because they change after every iteration. So let's say our start is 10, the end is 50. So in this way we can say that the start is 0, means the zeroth in position in the array equals start, and the end is equals to the uh, array dot length minus 1. We can say that because the array dot length is out of bound, this one, and we are going we want to choose the last element, so that is 50. So our start and end positions in the index are justified right now, the 0 and this one. Now the ranges are selected for the first iteration. What the binary algorithm does is that it also uses a it also uses a middle point, which in this case, if we see directly in the array, will be 30. But in terms of algorithm, we can say that mid is equals to start plus n divide by 2. We can say simply say that it is simply the average of the array, means the position of the array where the indexes are averaged. For example, if there are 1 2 3 4 5 and 5 divided by 2, we are going to use full numbers, so 2, so it becomes 2. So here we can say that 30th is the mid, but it will be choosing 20 as its mid. And when we talk about algorithms, we here we are using 5 elements, But in other cases where we don't know what the actual length could be of the array could be 1000, could be 10,000, there we can't simply just say that start plus end divided by 2, because the end could be infinite or near to the infinity. So in those cases, uh, in those cases, we have another way of simply expressing the end element, which is mid is equals to start plus end minus start divide by 2. It just simply turns up to the start plus end only by 2. So it is the same expression. We are just complicating it a bit, because the end itself could be a very big element when we don't know about what the actual length of the array is. So it is good. So when we simplify it, it will be start at 2 start minus start plus end by 2. This will turn to this, and the start cancels start, so only start plus end by 2. So it's just the same expression, we are just showing it in a different way. So now that we have our mid, we have all our three elements, the start, the end, and the mid. Now what the binary, now let's get to the actual core logic of the array. So let's say there are some elements in the starting position, in the start phase, uh, behind the mid one. Then there are some elements in, then there is one element in the mid, and there are some elements between mid and end. Now the now we can say, and our target is, let's say, 20. Now we know that the array is sorted, and we also have the target in our mind. Now in the original array here, we are going to use the sorted one. So in the original array, the target is 20. Now we know that whatever that there is a mid, we found a mid. So start plus end is 10 plus 50 by 2, 60 by 2, 30. Sorry, just my fault. It's actually just 30 only. So 30 is our mid here. Now we know that the 30 is mid when we find out in the first iteration. Now the target is 20. Now target is less than the mid in this case. There could be three. Let's talk about the cases once, because there will be three cases. The first could be the target uh, is let's display this in terms of start. The start element could be less than the target. Mid, sorry, not the start one. We will use the mid one. The mid is less than the target element. In that case, we can also say that if the mid is less than the target, then the mid will also be less than the elements that are between the target and the mid end position. So if this is true, then mid would also be less than all the elements that are present between the target and the end position. Sorry, the target. So we can say that we can simply omit that part of the array. So 10, 20, 30, 40, 50. If this is our array, this is our mid, and our target is 20 over in this case. If 20 is less than the mid element, then we can also say that 20 is also less than these, or than the elements that are after the mid, which is 40 and 50, which is also true. So we can simply omit that part of the array in our next iteration, because the iteration will keep running till there is a basic condition that is satisfied. And in this case of binary search, we can say that the target condition is start is less than end. If this condition is violated, if the start is greater than end, if that happens, then the loop will exit. So till the start is less than the end, that is our main base case, that is our main base condition. So we can say that while start is less than end, we can say that then we can put the checks. If the element of if the target is less than the array mid element, or there are other cases where we can say if target is greater than the mid element. And the third case where the target is actually equal to the mid element. And if that is the case, then we simply return the mid element, the mid index basically. It's up to us whether we want to return the mid index or the element. In general cases, we usually return the index. So we return mid. Alright. So in the third case, it is pretty simple that if the target is equals to the mid element, we are comparing the mid element every time. So if that is the case, then we simply return the mid index. Now, in this case, if target is less than the mid element, which means that it is in the first half, in the left half, where between the start and end, uh, the target lies in that position, that portion of the array. So we can simply omit the righter half, which is the mid and the end portion. We can simply, omit those part of the array, which in this case is this. We are simply omitting this part, and we will be looking in this part only because we know that the target is lying in this range only. So why even check the other half? We simply cut the other part. So the new array now we are going to check from is 20, 10, 20 and 30. We again do the same algorithm of finding the new start and new end, and in this case we know that the start is 10, the end is 30, and the mid will be 20. Now again we put the same three conditions, that if whether the target is less than the mid element, whether the target is greater than the mid element, or the target is equals to the mid element. Now we know that from this we can say that the target is actually the mid element, and if that is the case, we simply return the mid. And if that is not the case, then we have to check if the target is less than the mid element, we again omit the end part. If the target is greater than the mid element, then we omit the start part, and we again format a new array of those. So this keeps happening till we find our target element, and usually the match will only happen if the target is equals to the mid, because we are only returning the answer when we are getting the match, which is the mid is equals to the target. Otherwise you can see that we are simply you know uh, changing the structure, reducing the structure of the array if the target is either less or more than the mid part. If it is more, then we omit the first half, which is the start end to the mid, and if it is less than the mid, if the target is less than the mid element, then we simply omit the second half, which is the mid to the end part. So in those cases we are simply reducing the size of the array, and when and this keeps happening till start is less than end. This will only work till start is less than end. There could be one last case where if the element is not found, means if the target is not found, then the start will be greater than end. That will come. We will go through that try run case later. But if that happens, then we simply exit the while loop. And if the while loop does not return anything, means that no mid is found that matches the target, we can simply return -1 in this case, means that the target element is not found in the entire array. So the binary search, let's say there are four elements in the in the original, four sorted, very important thing, that binary search will only occur in sorted sorted array. So if there are four elements in the original array, uh, after one iteration it will go to 2. It will take its checking to the 2. If that doesn't happen, then it will go to 1. So we can say that it always reduces by half the array. The checks that are getting occurred are going to reduce to its half of the array. Every time there is a check, every time the loop iterates one more time after the other, the array gets reduced into half. So entire array, then to half, then to half. So every time it gets reduced to half portion. And this is why we can say that the time complexity of this algorithm is O log n by base 2. We will talk about the time complexity again in depth. There will be an in-depth session about especially the time and space complexity, because if you don't know what these time complexities and space complexities are, they are very important. Basically, in simple terms, we can say that n means the number of cases, and these complexities are usually tested when on the worst and the best case of the array. So on the worst case, which is this one, this is actually the worst case for this specific uh, array, where the array is reduced to its last part. Only one element is remaining. Till there it is reduced. There we can say that that is the worst case. So even in the worst case, it is going for O log n complexity. So O log n, if you don't know about time complexity, then O log n is very very fast, and it is actually faster than the simple constant n. O log n is faster than n base time O n complexity. It means even it is faster than the linear search, which is for linear search. This is for binary search. Binary search is much faster than the linear search, because it every time it iterates, it always uh, it always cuts the array, means it always partitions the array in exact half. It always reduces the array in half. It is exponential when we talk about the reversal way, that from 1 it goes to 2, from 2 it goes to 4, 4 to 8, 8 to 2 raised to n. So we can say that it always will be faster than the linear search. So in a way we can say that linear search should only be applied in cases where we want to use unsorted areas. Means there could be conditions or problems where some checks could be given that uh, don't sort the array, or the array is not sorted. Then simply use the linear search, or use binary search every time if possible, where there is sorted arrays or anything that is sorted. Simply use binary search. Don't even think about anything else. Just directly go for the binary search. uh, it is the only trick. It should click in your mind if you're going to solve a problem, and you can see if something is sorted, then directly go for binary search. Don't go for anything else. Linear search is good, but it's a brute force approach. If you don't know anything in this condition, where is the condition, let's say over here, the sorted, even in the sorted, if you are going to use linear search, then it is the brute force approach, where 20 will only come till all the elements before 20 in the array are checked. 20 won't come otherwise. Here it will come it will directly occur in the second iteration itself. In the first iteration, the array omits the 40 and 50. In the second iteration only, we will get the 20. So O log n, it is very faster than linear search. So that's why I use binary search. If the array is sorted, if something is sorted and you are going to have to search something, then go for direct binary search. Don't go for anything else. So I hope it's a good session, because we discussed about binary search and linear search. We will be going for many other search approaches. Then we will be solving some actual DSA problems related to binary search and linear search. I will also help you understand where exactly to use linear and binary search. I just discussed about it, but it won't be it will be pretty understandable once I start solving the problems. So I hope you are watching and give me some feedbacks and all, because I'm still learning how to use this YouTube thing. So I hope you help me out. Post some comments, like, subscribe. Subscribe is a very good thing for me, because I'm trying to promote my own channel as well. So hope this video has helped you understand something um, about the two types of searches. I hope it helps you. Thank you. I will be back with some. I will back tomorrow. I will be back tomorrow with other videos about searches and algorithms and all. Thank you.